Hey everyone, welcome back to Faraday Research. It's Monday morning, and last night and well, most of the day yesterday I was doing printing, and this is for the new Adams motor. As you can see in the last videos, my motor was spinning at a very high rate of speed. So I decided, because of I have to worry about safety a little bit, and I have to conceal everything and make everything safe to operate, because I'm working with high power now. So I designed this motor case on Fusion 360. Before we get into that, if you haven't subscribed, bottom right hand corner. Also, all my links are in the description for my Patreon, PayPal, all that stuff. Helps me build projects like this. And so I'm building the new Adams motor setup, so it's a lot safer. I can run it at higher speeds, and I don't have to worry about anything failing. And also to reduce the size of what I'm doing. So I made two parts yesterday. I made the bottom base. This is where the wheel's gonna sit in. This is just kind of a mock-up here. So it's gonna sit in here, and then the motor case is going to sit on top of this like that. Sit on top of it like this. I have to mock everything up. Nothing's lined up or whatever. I just kind of show you what I'm doing. So you got the wheel. That's the base. That's going to sit on there, and then the motor case is going to go over top of this. So after I get it all mocked up, then I have the spaces. I put two holes in there, about 23 degrees apart. This will be for the motor coil, and the other one's going to be for the proximity sensor. So I got it, I think I got it very close to the actual right angle between the coil and the proximity sensor. So yeah, we'll see how that turns out when I actually hook everything up. But this print here, as you can see, I got bearings inside, so I actually designed it to hold the bearings. Print took about 9 hours to actually do, so that took up much of my day yesterday. And then this little guy here, I also got the ceramic bearing in it, press fitted right in the base, and that took me about 2.5 hours to print. So yeah, all in all, it turned out really good. I got the design, so I can print off as many as I want. This thing takes forever to print, but I wasn't too happy with the finish that it had, because when I printed it upside down. So that first layer kind of looks crappy. I'll probably try to clean it up a bit, make it look a little better. But all in all, the print turned out really good, other than the finish on the top. But the bearing fit good. I just had to sand it lightly, and I press fitted the bearing inside. So I got the bearings there, got the bearings there, and yeah, so it's going to sit like this, and then the motor coil is going to go here, proximity sensors here, and then I can tap off as many coils as I want around it. Also, I was pretty happy with the actual dimensions of the wheel. So if you can see, I got from the top here that it's very close. So it's maybe about 1/4 inch gap all the way around. So it's very tight. And also too, it's to help reduce the amount of airflow, because air turbulence could actually slow the wheel down. So this is going to kind of like encapsulate the entire device. So it should be able to spin faster, and then I don't have to worry about magnets go flying off and hurting anybody. It's encapsulated now. So, and this is the base, and that basically holds onto the shaft there, and then this will be on a fiber board or whatever. Yeah, so all in all, it turned out really good. So I'm quite happy with the outcome of this. So yeah, let me know, questions, comments below. Give me a thumbs up for the video, and we'll see everybody soon.